All right, physics friends, let's do a problem together. Textbook problem 3-401 from volume 3. In the read step, we see that we have an oil slick on top of water, and they're asking for the thin film, thinnest possible, that will cause constructive interference for blue light. Our task, calculate thinnest film. To do that, we're going to use one of two equations. We do not have enough information at this point until we go through our draw step as to which equation will work. Just for reference, I get a lot of questions in class. Students go, which one of these is constructive and which one of them is destructive interference? That is not how you memorize the equations. One works in each other situation. There are three pieces of information we're going to have to put together. At the first interference pattern, did we go low to high or high to low? Did we get a phase shift? You then need to take that into account with the second medium and that actual reflection. And then we can say whether we need the half or not. Givens, wavelength 470 nanometers. The index of refraction of oil is 1.40. We're assuming that initially we have bombarded white light incident on the surface, and we're also assuming that air has a refractive index of 1 and that water has a refractive index of 1.33. So let's do the draw step. Initially I have incident light. I've just gone ahead and drawn it blue. Incident light on the surface. Now our rules are low to high gain pi, high to low no. So what that means is that on the reflection, and only the reflection from this first surface, this reflection, if it went from a low refractive index to a high refractive index, then we gained pi. That is true in this situation. What does that mean? It means that this wavelength went off by a phase of pi from its original incident wavelength. Now, that initial incident beam also entered the medium. It also reflected off of the oil to water surface. Now let's ask the same question. Did we go low to high or high to low? Here we went 1.40 to 1.33. 1.40 is bigger than 1.33, therefore we went high to low, no change. It will also transmit through this surface. I've not changed any of the angle of incidence to account for angle of refractions because it's not necessary to this problem. But we asked the question, according to phase, is this light off from the phase of the incident wave? And no, it did not go from low to high on any of its reflections from boundary conditions. Therefore, right now we have two different waves that are off by a phase shift of pi. The only way to bring them back into coherence and have no phase shift or phase difference between the two pieces of light is to add this extra half in. A phase shift of pi is also equal to half a wavelength. So when we go to our solve step, to get the two wavelengths back in coherence, we need to use this equation. A couple of things worth looking at in this equation. N2. N2 is the index of refraction of the actual oil, of the thin film. It accounts for the change in wavelength of the light inside of the film. The other part of the question says we need the thinnest. The thinnest would be when M is as small as possible. In this situation, we can put 0 into this equation. That would be the thinnest film. If we went back and looked at this equation, and I put M is equal to 0, that means that thickness also goes to 0, and we haven't done a problem. That's nonsensical to say that our thin film thickness is 0. Here it does work because we still have a value equal to T. So here the thinnest is 0. If you were to use this equation, the thinnest would be 1. Solving for the thickness, M goes to 0, therefore I get 1 over 4, 1/2 times 1/2 over N2. Substituting in our numbers, again using the refractive index for the oil, When you put all these numbers into your calculator and round for significant figures, I get 84 nanometers. Important things to clarify. Coherent light has the same phase. If you are off by a phase of pi, then you are incoherent. From this situation, these two light rays are incoherent. You would perceive them as a dark spot. You would not see a light. Your eye would not register an intensity because they are destructively interfering. Therefore, we had to artificially change the length of this surface with this equation. That equation was here. We then went with the thinnest film, which is m is equal to 0. Therefore, this is the thinnest film possible of the oil that would cause constructive interference of our blue 470 nanometer light. Let's do the check step. Units, base units of meters, significant figures, I went with 2. Does that make sense? With 470, I only have 2 sig figs in this number, therefore I should stay at 2 sig figs, and my answer seems reasonable. Thanks for tuning in. See you next time.